Okay, this video is a tutorial on what to do when your Lenovo W540 laptop won't boot up. Basically, it comes up to the boot screen, or you hit F1, F10, F12, you try to get into the BIOS or the recovery panel or boot from something else, and it just sits there staring at you and it just won't go any further. So what you're going to need to do is basically you're going to need to prepare the BIOS and flash it again. So for this you're going to need some sort of SPI flash programmer, some sort of USB device. I got mine off of Amazon. It's an EZP-2019. You're going to need some sort of hex editor. Everybody's favorite is HXD. You're going to need a BIOS editor, and the one I use is the UEFI tool, which I got from GitHub. And make sure you get the version 0.26.0. And you're going to need a newer BIOS file from Lenovo. You're going to take the good parts out of that BIOS file and you're going to stick it in your old BIOS file. You just can't use the new file because there's a lot of information in your BIOS that's specific to your own particular hardware, and that information isn't in the new BIOS file. So the first thing you gotta do is take your motherboard out. I won't be going into that. I'm just gonna give you some information here that you can get the hardware maintenance manual from Lenovo, and then in the hardware maintenance manual it gives you all the sort of instructions. We'll zip down here where the screws are, how to take everything apart, the tool for, the first thing you have to do is take the keyboard out, and where the screws on the back are and where they should all go, and that will help you get the motherboard out. So once you've got the motherboard out, you're going to need to get to the back side of the motherboard, and in this area here are the two BIOS chips, and these are the ones we're going to stick our programmer. This is the EZP-2019 programmer, and so we're just going to clip it on here. You'll need to know which is pin 1, so we're going to zoom in a little bit. The two chips for the BIOS are a 25Q064A and a 25Q03213. Now these chips aren't programmed in the EZP-2019, but they are exactly the same as the WinBond 25Q064 and the WinBond 25Q032. So when we get into our programmer, we'll have to tell our programmer which one that is. And so from the little dots here, you can see that's the pin 1. We'll zoom out. There's the pin 1 again. And pin 1, and here are the chips. And so you have a better idea of where you're going to need to put your EZP programmer clip. Okay, so we're going to read in the BIOS from each of the two chips, the 32 and the 64. We'll combine them into one bigger ROM file, and that ROM file we can then edit with the UEFI tool. At the same time, we're going to download a new BIOS from Lenovo, and then we're going to switch out the BIOS component of the new file with the BIOS component in the old file. We'll save that, and then we'll take that big new ROM file and we'll split it into two smaller bin files that we're going to then program back into the EEPROM chips on the motherboard using, again, the EZP-2019. Then you need to reassemble your computer and try it out. Now, just so you know, this procedure will not remove the supervisor password. That password is not stored in the EEPROM. So if you think, oh, I can't get into my BIOS because I don't remember the password, this is not the solution for you. Okay? Now before we get started, I'd like to just say a few things about the EZP-2019 that I got from Amazon. Now, just so everybody knows, this is pin 1 up here, pin 4, this is the ground, so pin 1 would be up in this top corner, pin 4. Now, the next 4 down here and the next 4 down here, this copy thing, there's nothing actually attached inside the box. So this copy function, if you're thinking of using the copy function on mine, anyways, this doesn't work. There's nothing physically attached. Okay, so this is with the clip attached. Pin 1 is here up in the top corner and coming down here. So just make sure that when you connect up your clip, you connect pin 1 on the clip to pin 1 on the chip. So there's the 25Q032 clipped, and not that you can see much, and the 25064 clipped. Okay, again, pin 1 is on this side. There's only one way to get this clip connected with pin 1 on this side. So you shouldn't have too much difficulty if you remember that pin 1 is close to these two chips, is on this side of the. Now one problem I did run into, that pin 4 on this ZIF connector isn't actually physically connected to the ground in the USB. It's connected into this chip, and then through this chip gets connected to the ground, and so then when you start doing things it turns the ground on, and then your chip is activated. Unfortunately, the ground connection on mine doesn't work really well. It says it's 3.3 volts between the source and the ground, but then when you plug it onto a chip that's actually on the motherboard, that voltage will drop. It just can't supply enough voltage or enough current to keep the voltage at 3.3 volts. So what I ended up doing was just grounding pin 4 directly to the ground on the USB. After doing this, when I connected the chip on, or the clip onto the chip, it was able to provide the 3.3 volts, and then I had no problems doing the programming. It took me a little while to figure that out, but I don't know if other people's EZP-2019 does that as well, or if it was just mine. Or so if it's not working, that might be a reason why you aren't able to program the chip if it's still attached to the motherboard. You might have to unsolder it, or you might have to do something like this to get the unit to work properly. Okay, so we're going to connect the EZP clip to the Q25032 chip right here and run our program. And you can see it's ready. I'll just unplug it and it'll say not connected. Plug it in, it's connected up, and then we'll do a test. And it comes back and says unknown chip ID 20BA16. Please choose the compatibility type manually. Now, like I said, this chip wasn't going to be in the database, but we know which one it's going to be. And we can go to device, and it's a WinBond. Zip down here wherever WinBond is. There it is. 25Q32. Double click on then. We'll just call that Lenovo, and we'll call that guy 25Q03213. And in the ID, it's going to be BA16. Now before we save that, one thing to point out, the database file is marked as read-only, so we'll need to uncheck the read-only, otherwise we won't be able to save the changes we just made. Okay, so now we'll say save, and we're just going to go in and we're going to check at the bottom. I don't see it there. Oh, we have to say add first. Add, there it is. Okay. And then we're going to check out the 25Q03213. That's our 4 megabyte chip. And because I've run this before, go back into the WinBond, go down to 25Q64, and we're going to call this one Lenovo Q064A, and it was 20BA, and it's 17. The other one was 16. This one will be 17. That's just the ID on those chips. I just happened to check that out before we got in, where we'll add that guy in, and then we'll save it, and we quit. Just quit the program, run it again, go to device, Zoom to the bottom, and then there's our two chips. And those are basically the operating parameters for those two chips. So now if we do our test, it says, oh, the chip was detected, it was a 25Q3213, blah, blah, blah. Okay, and all we need to do then is just read it in. The progress bar for the read, the write, and the verify should proceed smoothly along the bottom. If it doesn't, you've got a connection problem. You'll need to recheck and test the clip connection or possibly the USB connection. You may also need to restart the programmer. The erase procedure is much shorter and will jump out about halfway through. Read complete. We're going to save that. I'm going to call that old 32.bin. And we'll just clip onto the 64. And we'll hit test. And it didn't come up with it, so it's probably not a good connection. There we go. And we're going to read that guy in. This one will take longer. It's the 8 megabyte chip, so it'll take twice as long. We'll just speed up the video clip here. Okay, read complete. Looks good. And now what we're going to do is we're going to take the two bin files that, oh, I forgot to save it, didn't I? Save. Old 64.bin. Okay. Okay, now we're going to create our bigger ROM file. We do that with the hex editor. We'll take our old 64, our old 64, add the 32 in. From the 32, we'll just copy everything. Copy, go to the 64, and at the end of the 64, we'll append. Okay, we can say file, save as old BIOS.ROM. Okay, now what we're going to do is we'll just pop over to the Lenovo website and we'll look for W540 BIOS. Lenovo W540 BIOS. Support. Okay, and we want to figure out which BIOS we had. I don't recall. And the BIOS IDs go by gnet something. So we'll go into our file here. Make sure we're at the top. Search, find, what is it? Gnet. Just say gnet. That's not right. Search, find again. There we go, gnet. So gnet 88. So our last BIOS was gnet 88, which is this one. So it's ECP, it's an embedded controller, is a 114. So we'll pick the most recent 114, which is this guy. Save to BIOS, okay. And there it is. Don't need that anymore. And we're going to extract this. Yes. Next. I accept. Next. Copy. Paste. BIOS. Next, install, but we're not actually going to install, we're just going to finish. And right there, this copy, paste, and there's our new file. I'm going to do that for a moment. To our okay, we're going to get our BIOS editor. We'll go back and we'll look for GitHub and UEFI tool 0.26.0. Here's the tool. That's the tool. Okay, and just going to drop it in there. Extract here. Okay, so we'll take the UEFI tool and we'll grab our old BIOS. So this descriptor region that describes your own particular computer. Here we come down here, we can see some of the EEPROM chips on your motherboard. So here are the two chips. These are the two BIOS chips that we encountered earlier, the 20BA17, which is the 64 or the 8 megabyte chip, and the 20BA16, which is the 32 or the 4 megabyte chip. So we're just gonna zoom up a little. We'll run the another tool down here, and we're gonna grab our new BIOS file and we're gonna drop that in here. So that's a capsule that contains so all of this we're going to keep the same. This is all particular to your own computer, and this BIOS region, that's what we get from the website. So here we've got a 7A9 and a 9E21, 7A9, 9E, FF12, and an 00504. So coming down here we see 7A9, A9, 9E. Okay, so there's the 9E. So this guy we're going to save, extract the body, and we'll call that 9E.FBD. So that's the 9E, the FF. Okay, here we'll come down, we'll extract this body, we'll call that the FF dot volume body, and the 0504. So we'll extract the body from the new one of the 0504 dot BBD, and 7A935, that's with all the pad, the ED52, that's ED52, 27A, that's this guy here. So this guy we're going to extract the body. BD, and we saved all those. And we come in here, and the 9E, this is our original BIOS. We're going to replace body, and that's the 9E. And then the FF, we'll replace that body, FF, and the 005 7A. Okay, so remove, replace, remove, replace, remove, replace, and it'll rebuild everything. So we're going to file save, save image. This is going to be our new BIOS. Save. Do we want to open it? Doesn't matter. Open it, we can take a look at it. So that's basically our same BIOS. Everything looks the same as we had before, but it's now have all the new BIOS information in it. And we don't need these guys anymore. So we'll go back to our hex editor and we'll take the new BIOS ROM, go in, and we'll go down to 7F. Now the top 8 megabytes of this new ROM file will become our 64 bin, and the bottom 4 megabytes will become our new 32 bin. A, B, C, D, E, F. Okay, and so from here all the way to the end, edit, cut, file, new, paste. Okay, and then this should be, that's 4, right? So we're going to save that. File, save as. This is going to be called new 64.bin. Wait a minute. No, that's new 32.bin. Save. And this one, which is only 8K, 8 meg now, so we'll save that file. Save as new 64. .bin. Okay, so we have our new 32 and our new 64, and we can program those guys in. We'll close this guy down. Okay, once we've got our new BIOS, all we need to do is go back to the programmer. It should be still in the last one. We'll test. Okay, and we're going to erase our BIOS. This doesn't take quite as long as reading or writing. You have to erase the BIOS before you can write it. You can't just overwrite it, so you have to have a blank chip before you continue. We'll just speed up the video clip here. Okay, we could read it to make sure it's all 0, but we can just open the next one. If it doesn't work, then we'll know. So there's the new 64. Open, and we're going to write. Zoom, zoom. Okay, write complete and verify, very important. Zoom, zoom. And verify complete. So we'll connect onto the 32. There's the 32. Open our new 32. Erase. Zoom, zoom. Erase complete. Can't remember if I opened it. Open new 32. Right. Zoom, zoom. Verify. Zoom, zoom. Okay, the verify is complete. Now all we need to do is reassemble everything and test it out. And I'll do that now and pop back. I'll let you know everything worked. Well, we've reassembled the laptop and lo and behold, it worked fine. I got into the BIOS, set all the parameters, booted in the operating system, went to Lenovo, downloaded the latest BIOS, installed that, shut it down, reboot. No problems. Everything looks good. Anyways, I hope this video helps somebody else out. This was in fact my very first video.